Starting the last section of Chapter 5 today, solving systems of equations and systems of inequalities. I'm sure I'll say this a few times throughout the lesson, but I want you to remember that when you're solving systems, the solutions are coordinates. So you want your x and your y for the coordinate. Let me just lock this page.
Okay, and then here's what's happening.
All right, so make sure once you find the x values, you go back, substitute in the x, and get the y value. All right, so in the set of real numbers, if we're looking at real numbers, a quadratic and linear system could have two solutions. Here's an example. It could have one solution, the system. There's an example. Or the line in the parabola could have no intersections whatsoever. So we would show empty braces. Here we would show the point, the single intersection, 4, 1. And here we would show both intersections, -1, -2, and 3, 4. So remember, like I told you at the top, the solutions to a quadratic linear system are the coordinates of the intersections of the line and the parabola. So we'll just get a little warmed up here, taking a look at this picture here, which might be sort of hard to tell, but we'll do our best. Circle the common solutions from the graph. That's easy. We can circle that and that, so there would be two solutions. And the common solutions here, it says determine the common solutions. So I see one there and one there. And let's see if we can count and see what those 2 points are. This one on the right, 1, 2, 3, 4, 5, looks like 5, 0. And this other one, let's see, -1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, or 12. Let's go with -1, 11. It's pretty hard to tell, but that looks good. So typically what we're going to get is a couple of equations, and it will say either solve graphically or solve algebraically. So this first one says solve graphically. So you want to get your calculator out. And we're going to put these into our y equals. Well, what you might first notice is that neither of them are in the y equals form. So in the top one, I'm just going to bring this y over by adding it to the other side. That will look like this. So I see I'm going to get an upside down parabola because I have a negative in front of my x squared. So we'll expect that. And the second one, I like this y on this side because it's positive. And I'm going to subtract over the x value then. So I have 4 minus x if I subtract over the x value. Okay. So in the first equation, I took the y over because it was negative. In the second equation, I left the y where it was because it was positive. So now that I have 2 equations, let's go put those into the calculator. So y equals -x squared plus 4x doesn't want to press. There we go. Minus 2 terrible lag here. All right. Negative x squared plus 4x minus 2. Great. And my other equation for subtraction x, 4 minus x. So I will do a zoom 6. Remember we had changed our windows when we were graphing word problems. The window is nice. It's definitely fitting both graphs, but I need to improve it a little bit. I want to see how many times this really intersects. And right now I can't actually tell very well. So I'm going to do a zoom in. I'm going to zoom in. That's choice 2. And I'm going to hit enter again. That should improve my window a little bit. But we need now to see a little bit farther to the right. So now I'm going to hit window. And farther to the right means I need to increase my x max. So I'm going to put 4 in there. Hopefully that's enough. Now hit graph. I just want to try and see both intersections if there are 2. And I want to see a full parabola as well. This looks pretty good. Looks pretty good. So to find intersections, remember our steps are second, trace, intersect, and find the flasher. That's our first curve. Hit enter. Then it goes to the line. Can't quite see it right now, so I'm going to bring it down. You can see the values changing on the bottom of your screen. There it is, coming in down the line. I'm going to hit enter again, and then I'm going to put it near that first intersection. Terrible lag on mine. 2, 2. X equals 2, y equals 2. That's our first intersection. Let's redo those steps. Second, trace, intersect. Now we're going to go find that other point. So you do want to move the flasher down a bit. That is our first curve, the parabola. And the line is our second curve. I'd like to keep moving it down toward that other intersection. And I will hit guess once I'm closer. So the other intersection is at 3, 1. So we found the coordinates of the intersections. 2, 2 was one point, and 3, 1 was the other point. So that was graphically. And remember those steps. We had second, trace, which brings up a nice menu. We chose intersect. And then basically you just need enter, enter, enter. But you do need to be close to the intersections. All right. We're going to do that same question algebraically now. Algebraically means they want to see all the algebra involved. Well, we know for starters that these both changed, y equals and y equals. So we're going to solve our equations for y, and then we substitute one of them into the other. We know that if they both equal y, we can substitute by putting this into that y, or vice versa. Or you might have called that setting them equal to each other. So we have a second degree. We're going to get it equal to 0. Add x squared over. We like it to be positive. Subtract 4x over. So we have minus 5x. And add 2 over. So we have plus 6 and 0 on that side. So it looks like a nice quadratic. Maybe we can factor it. If not, maybe we could complete the square. If not, maybe we could use the quadratic formula. So let's try factoring first. Multiplying to positive 6, adding up to negative 5. Both sides are negative, so we have a negative 3 and a negative 2. So this is real easy to solve. X equals 3 and x equals 2. And here's where we run into trouble. A lot of kids stop right here. We need the y values that go with these x values. So this is where I really need you to remember. When you have a system, your solutions are the points of intersection, the coordinates. So we know we're going to have 3 something. We know we're going to have 2 something. We want to take these 2 values and put them back into one of the equations. I would use the easier, of course. So for the 3, we would have 3 plus y equals 4. And of course, then y is 1. And for the 2, 2 plus y equals 4, and then of course y equals 2. That's a 2. And lo and behold, we come up with the same solution set as the previous problem, because it is the exact same problem. 2, 2, and 3, 1. All right, let's try the next example. It says solve this system. So let's do this algebraically. They're both already set equal to y. Go ahead and pause if you'd like. I'm going to start by setting them equal to each other and then going through the work quickly to solve for the coordinates. I'm going to try factoring. I can see they both need to be subtraction. 2x minus 1, x minus 3. That makes for some very nice x values. And now go find those y values.
Now, there are 3 roots, however,
So I will use the easier equation of y equals x plus 4. Once I know the x, so 1/2 plus 4, I'll just put 4.5 or 4.5 or 9/2. And the other y value is 7. So it looks like we will have 2 points of intersection. 1/2, 4.5, and 3, 7. Now, just so we get a little practice, I'd like to graph both of these functions and get some practice setting up axes, etc. So first, let's draw in our axes. Most of the time we do it without looking first where the parabola might be, but I think we're going to throw a little caution in the wind here. Label your axes. Something a lot of kids forget. Label your axes. So let's see, if I put into my calculator, and I'm just going to do this on the side, y equals 2x squared minus 6x boy. There we go. 2x squared minus 6x plus 7 and x plus 4 go. Zoom 6. There's the parabola. Here comes the line. So indeed, I do see two intersections. If I wanted to check it graphically, I could go in and second trace, intersect. But what I want to do here is actually transfer these graphs. So you might want to set a nice table and then check out your table. And let's plot some points. Practice graphing. So one of the points for the parabola I see is 1, 3, whoops, and 2, 3, 0, 7, and 3, 7, and a little smidge right there. So, see if I get this. My orientation is off just a bit. Parabola looks something like that. Great idea to label your graphs. So I'm going to put a label on this. Y equals 2x squared minus 6x plus 7. And then the line coming in, y equals x plus 4. I know it has a y-intercept of 4 and a slope of 1. And so, let's see if I can get this straight. My orientation is off just a bit. Label this, y equals x plus 4. And then when you're doing a system of equations, you circle those solutions. And we have them written down here, of course, but you could also write them next to the points. All right, so remember to label your axes, and remember to label your graphs. You can actually lose credit when you don't label, so that's very important. Wanted to go over that with you. Let's take a look at the next page. So now we're moving into inequalities, and the important part about inequalities is that there's shading involved. So we need to know which way we're shading most of the time. Let's take this first example and bring this 2 over. So we have y alone. We want y alone, and we have a parabola on this side. So we're going to graph the parabola first of all, and then we're going to decide whether we're shading above the parabola or below the parabola. Label axes, and let's plot this parabola. You're going to plot the parabola. If you want to use your calculator, you're going to put in y equals x squared plus x minus 2, of course. Right? One, two, three, 4. All right.
All right, so here are the S steps for this. All right, solve one equation. For y.
So this is actually y equals x squared plus advice here for how you do your shading. Choose a point to test, and we're looking at, you're either choosing a point in here, okay, or you're choosing a point out here. Typically, we will suggest just try 0, 0. Try 0, 0 in the original problem. Here's 0, 0 right here. If 0, 0 checks, then you shade inside. If 0, 0 doesn't check, you shade outside. So let's throw 0, 0 into, it's always a good idea to use the original. 0 plus 2 is less than or equal to 0 squared plus 0. 0 is real easy to work with, and that's another reason why we suggest 0, 0. So we have 2 is less than or equal to 0. Well, that's a false statement, so we don't shade towards 0, 0. Shading then is below the parabola. Below the parabola. Try and be a little neater than I was. You don't want to hit it, you want to be below it. Okay? And I like to look, if I see y is less than or equal to, actually we can hit the parabola, y is less than or equal to, then I think of less than as meaning below. So I know wherever the parabola boundaries are, I'm shading down, below. Okay? So sometimes you'll just get less than and just greater than. The problem we just did was less than or equal to. If you just get a simple less than or a simple greater than, you need to use a dotted line. It's not a line. You need to use dashes for your graph. So these are all basic parabolas. I chose just a basic parabola. So let me just sketch in 4 basic parabolas, and I'm dotting them because they all say less than or greater than. Okay, I'm going to fix this one up a little better. All right. They all say less than, greater than, less than, greater than. So now let's talk about the shading. If it's y is less than, we're shading under. Y is greater than, we'll shade above. Y is less than, oh, I messed up. Oh, wish I could back up. I did not look. Negative x squared is this parabola. I'm sorry about that. So y is less than is lower, y is greater than is above. So whether the parabola is upside down or right side up, you're still using that idea of below and above. So let's see what we have on the next example. We have x squared, we have a y. Let's bring everything over. X squared, subtract 5x, add 6, and then we have less than y. I'm going to flip that whole thing around. I think you'll feel better. Make sure that the y greater than. Flip it all around. So we have a parabola. We know we're going to have a dashed graph, and we should be shading above. But we can still go check the point, 0, 0, to make sure that shading works. I'll leave that graph and problem for you, and we'll take a look at it in class. There's one more thing I want to make sure we get to, and that is a quadratic and a linear, and shading that solution set. So let's go ahead. I think these are all set up. Let's put our parabola and our line on a set of axes. Label those axes. And we have y is greater than x squared minus x minus 6. So dashed line. And we should be shading above the parabola. And then we have y is less than x plus 1. Dashed line, and that really is a line. And we should be shading below that line. So I'll do the parabola in red. I can figure out a couple nice points here. Put it in your calculator. I've already done mine. 0, -6. Work. 1, -6. Looks good. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. 6. I want to graph as neatly as you can. Use your table to get some good points. Since we're going to have two graphs, we want to label it. And I just broke my promise. I needed to do a dashed line. It's another good reason to graph in pencil. So I'm going to grab my handy eraser here and just sort of dash it out. Dashed because it's just less than or just greater than. Okay. Good. And the line, put that in as well. I see an intercept of 1 and a slope of 1. And this should be dashed as well. So I will dash this as well. Careful. I always forget to draw a dashed line, so I understand. But I think that's one of the reasons I write it. And then when I go back and look, it's a nice reminder to fix it, as you just saw. Let's see, this is actually y equals x plus 1. Okay, now the shading for the parabola, if you want to check 0, 0 for the parabola, it works beautifully. 0 greater than 0 minus 0 minus 6. So 0 is greater than -6. We do shade for the parabola. We do shade towards 0, 0. So I would be shading my parabola greater than inside up like that. For my line, we had less than, and we were thinking below the line. Well, 0, 0 is also below the line, so I'll check that. 0 is less than 0 plus 1. Yes, 0 is less than 1. So that is the right way. Below the line means I'm shading here. So shading the solution set or labeling it, you may remember your teacher asking you to put an S in the solution set. So our solution set is actually the overlap of the shading. The overlap of the shading. And 0, 0 is part of that. Kind of nice. So much like this question here, we have some shading. We have shading above the parabola and shading below the line. And this one's asking us to determine the inequalities that produced this. So let's see what we can do here. The line is actually probably the easiest part. A y-intercept of 6 and a slope of 1. So the line has this equation, and it's shaded below from the line. And it's solid. So the line would be y is less than or equal to x plus 6. So let's try and figure out the parabola now. The parabola is definitely shading above, so our y is greater than or equal to. We've got, what I see, 2 roots, and the roots are -6 and -2. They're sum of those roots is -8. The product of those 2 roots, I'm just adding these together and multiplying them together. The product is 12. And putting that together to make my quadratic, much like we did on that quiz, x squared, opposite of the sum, in front of x, and the actual product. So there's our pretty good guess at that parabola. And it is shaded above. And put those into your calculator. Give them a try. I think you'll see we did it right. All right. That's it, kiddos. Come in tomorrow with some good questions. Got our test on Friday. Hope you enjoyed your day off. And see you Wednesday.